Coming up next, an Astronomy.fm original program. It's time for York Universe, a co-production of the Observatory of York University, Toronto, and the Voice of Astronomy. AFM Radio, AFM Radio, AFM Radio, AFM Radio.
Welcome to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, alumni, not to mention the darn good friends of York University. I will be one of your three hosts this evening. Yes, the three musketeers. Good evening, Sana.
Hi.
Hi. And then there is Ariella.
Hi, everyone.
And for everybody's benefit, we are talking about Pluto tonight.
Yes!
Yeah. Broadcasting live from the Alan I. Carswell Observatory, located at York University in Toronto, Ontario, Canada. And this, of course, it's Monday night. It's therefore Astronomy Night in Canada, where the lineup is entirely Canadian, starting with ourselves, York Universe, on to Western world's quirks and quarks, not to mention science for the people. York Universe broadcasts every Monday night, 9 p.m. local Toronto time. That's Eastern time. Or, of course, that's Tuesday morning, 1 a.m. Universal Coordinated Time. The York Universe production works in concert with our online public viewing program. Hi there, Observatory team. And they operate at the same time as we do, from 9 till 10 p.m. local Toronto time. By all means, please point your favorite web browser to observatory.info.yorku.ca and follow the links to OPV, online public viewing. Of course, you can reach us as well through our YouTube channel. Pop into YouTube and just type in York University Observatory or Alan I. Carswell Observatory, and you'll find the live link right there. Our broadcast is powered by and is in partnership with Astronomy.fm, the voice of astronomy. If you've got any questions or comments about past shows or suggestions for future topics, by all means, send us an email, observe@yorku.ca. You can always connect with us on Twitter or Instagram with the handle @York Observatory, or, of course, on Facebook at Alan I. Carswell Obs. All of our programs are free, but if you would like to make a donation, by all means, visit our website, observatory.info.yorku.ca, and look for that big, friendly donut button. We will, of course, be monitoring the chat room for commentary. There is clear skies, slightly hazy because of some wildfires north of us, but by and large clear. The observatory team is on deck for the 1-meter telescope. So by all means, if you're listening live, pop on over and have a look at some of those images. Ladies, how has summer been treating you? Well, I hope.
Yeah, very good. Enjoying the 3 days of good weather we've had.
Well, it's been certainly nice and warm the last couple of days, slightly cooler tomorrow, but clear for a change.
Yeah, that's been really nice.
Yes, absolutely. I guess neither of you have done too much observing, though, this summer.
No.
No.
Well, I haven't taken my telescope out in a while because the skies near my house are just really not good. So,
True.
To take it, yeah, if I want to be able to really observe anything other than maybe a couple planets or the moon or something really bright, I have to take it to the park, and that's just a whole thing.
Yeah, bit of a rigmarole. Hey, have a look at Venus. It's over there in the western horizon, climbing. Great opportunity to see it work its way through the phases. And, of course, it will shine through your local light polluted skies. And what about you, Ariel? Gone outside with even binoculars, had a look around?
Well, I have a gorgeous telescope my dad bought me. I just haven't used it much. Last time I think I used it was when the Mars opposition, which was a while ago.
Yeah, that was a bit.
Yeah, I gotta take it out because I got some beautiful filters for it, especially to see the moon, which I think is probably one of my favorite things to see through the telescope right now.
Oh, the moon is a favorite object for anybody, and I don't care whether or not you're a first-time user at sort of 5 or 6 years old, or whether or not you're a retiree at 70 or 80. The moon is fabulous, always is, absolutely. Very good indeed. Sana, you're almost a graduate student.
Yes.
Yes. Very, very good, and it's feeling good, right?
Oh, yeah. Yeah, I've already started working on the project I'm going to be doing for my master's, and it's so cool.
Excellent, excellent. That's what we like to hear. And I would strongly suggest for the month of August, catch up on your sleep, because come September, you won't have much time for it.
Yeah.
All right, let's get rolling, ladies. Let us see where we are going to end up. Sana, take us to the moon, please.
Okay. So July 31st, 1964, which was the impact of Ranger 7 on the moon. So Ranger 7 was one of the early lunar exploration programs launched by NASA in the 1960s, which was leading up to the Apollo missions. The goals of all of the 9 Ranger missions were just to take the first, or NASA's first, high-resolution images of the lunar surface, transmit them to Earth, and then just crash into the moon, which is referred to as a hard landing. These images were necessary to help plan for the upcoming Apollo missions because NASA needed to determine if humans could land safely on the moon, and if yes, where in what regions of the moon was that going to be possible. Well, at the time of Ranger 7's launch, without being too mean, NASA's lunar exploration program had kind of been failing spectacularly. They suffered about 13 consecutive mission failures, which include Rangers 1 through 6, and then some failures also in the Pioneer program. Some of the failed probes were just never able to leave Earth orbit, and of the ones that did, they either missed the moon or they hit the moon, but they failed to transmit the images. But things started to turn around for NASA with Ranger 7, which was an incredible success. It returned 4,316 images of the lunar surface, which were all taken within 15 minutes of its impact, using a suite of 6 cameras. It then crashed into the moon in the northern rim of the Sea of Clouds. After spending a couple days processing the footage from Ranger 7, NASA scientists finally had their first high-resolution look at the lunar surface, with its images in some cases having resolution 1,000 times better than what they could get from ground-based images. The pictures from Ranger 7 helped NASA to determine that astronauts would be able to land safely on the moon in the Mare regions since they were relatively smooth, and it also marked NASA's first hard landing on the moon. The Ranger 7 mission was kind of a turning point for lunar exploration with NASA because they started to have a ton of success after this. They went on to replicate many of the firsts accomplished by the Soviets, including the first soft landings with the Surveyor program. NASA was also able to use the remaining 2 Ranger missions in combination with the Surveyor missions to pick out the best landing spots for Apollo.
It's hard to imagine now, in the 2020s, the difficulty that NASA was having in those early days of the 60s. Remember, when this was launched in 1964, it was barely 2 years after they had managed to successfully launch John Glenn into orbit. And here they were shooting at the moon. And as you so eloquently pointed out, they missed on several occasions. Now, I mean, really, how can you miss an object 3,500 kilometers in diameter? But nonetheless, they managed to miss it several times and finally got their act together with Ranger 7. And after that, things went along swimmingly. As I said, it's hard to understand the list of failures back then, given the great success that has ensued, particularly this century with NASA missions.
Yeah, I mean, it's kind of insane when you think about it, how hard it is to even just hit the moon because it's so far away. Like, even something as simple as just sending a probe to crash into it is like the amount of work that requires.
Yeah. It's absolutely correct. That's right. I mean, even the Soviets in the early days trying to fly a spacecraft behind the moon, also very, very challenging. Things that sound so simple, and we make them simple today. But back 60 years ago, this was all brand new technology, and something as straightforward, and I put that in quotes, as launching a rocket, let alone wherever it was going. Launching the rocket from the launch pad was a big deal. There were many, many absolutely glorious disasters of rockets blowing up on the pad in the early 60s, not with people on top of them. But here is your blood, sweat, and tears going up in this monumental fireball on the pad, and you go, oh, again? It really was a challenging time there in the early 60s. It began to pick up in the late 60s, but it's really been the last sort of 20 to 30 years where spaceflight has become truly routine. But you never want to get complacent. There's an awful lot of energy associated with a rocket launch, and you've got to do it perfectly right. Have you ever seen any of the images that the Ranger probe sent back?
Yes.
Yeah. They are
They're
quite
amazing.
impressive, despite the fact that, it's 1960s television technology. But, as the spacecraft was getting very close to the moon, it really was high-resolution stuff. Some of those images were taken from hundreds of meters and then tens of meters and then centimeters above the lunar surface. Good stuff. Good stuff. Ariella, our Canadian content for the evening.
Yeah, so we have a birthday on August 1st of 1905. Helen Sawyer Hogg, an astronomer who pioneered in globular clusters and variable star research, which is all we know, very close to our hearts at the observatory, was born. She was an astronomer and educator who was recognized internationally for her research on globular clusters and significantly advanced astronomers' understanding of the location and age of stars, as well as the origins and evolution of our galaxy, which is the Milky Way. She went to Mount Holyoke College, where she received a BA in 1926, and then later at Radcliffe College got her MA and PhD in astronomy. Her PhD research mainly focused on variable stars, which are stars with fluctuating brightness, and globular clusters, sphere-shaped formations of stars and the oldest parts of our galaxy. In 1936, Sawyer became officially affiliated with the University of Toronto, very close by, Department of Astronomy as a research assistant. She then became a full professor in 1957 and was named Professor Emeritus upon her retirement in 1976. She used the very famous David Dunlap Observatory's telescope to take thousands of photographs of the Milky Way, which of course is where we are located in. Through research and analysis, she produced more than 200 scholarly reports and articles. And as someone who has only one paper in process of publication, I can say one is a lot. I can't imagine 200. Sana, you might feel this way too. Given this work's importance to the astronomical community, updated editions of her papers were printed in 1955, 1973. This was the main paper that she had, including a catalog of 1,116 variable stars and clusters. She was a program director for astronomy at the U.S. National Science Foundation in 55 to 56, and the president of the Royal Astronomical Canadian Society of Canada from 57 to 59. She was also the founder and inaugural president of the Canadian Astronomical Society in 71. I could go on about her awards, but there was way too many. The National Museum of Science and Technology named its observatory in her honor in 89, and the University of Toronto's Southern Observatory in Chile named its telescope the Helen Sawyer Hogg in 1992. She won the Annie J. Cannon Prize from the American Astronomical Society in 1950 and was the first Canadian and second woman ever to win the Rittenhouse Silver Medal in 1967. In 2004, she was posthumously inducted into the Canadian Science and Engineering Hall of Fame, and of course she won many awards as well, but she was obviously a great hero in triumph and pioneer for women in astronomy, and so happy birthday to her.
I was lucky enough to meet Helen at my first... Sorry?
No, I said that's incredible.
Oh, sorry. Yeah, I managed to meet her at the joint meeting of the RASC and Casca in 1980, which was over in Halifax, and she was a very lovely person. It's as simple as that. I mean, you hear many fine things about her, both from the RASC, the Royal Astronomical Society of Canada, as well as Casca, the professional equivalent, and they're all true. She was easy to talk to over breakfast. She was very knowledgeable. She was very flexible. She gave lots of encouragement to graduate students, which is what I was at that point in time. And of course, she believed strongly in outreach. She wrote a column for the Toronto Star. I'll get the newspaper right here. For something like 15 to 20 years. She just did everything. She really was that good. And the fact that she won all of those awards, she was the inaugural president of Casca here in Canada, all incredibly well deserved. And yeah, she loves stars, variable stars. Doesn't hurt as far as I'm concerned. Okie dokie. Moving right along here. Taking us back to 2005. Okay, now Ariella, I do want you to be calm, okay, as we go through this little article. Okay, so it was July 29th, 2005, and the announcement of the was announced. Now, Eris. This has become a bit of a flashpoint for anybody who has been following the saga of Pluto's changing designation from planet to dwarf planet. Eris was known as 2003 UB313 initially, because of course all of these objects are first off found as tiny little streaks in the night sky, and then we have to figure out where the heck they are and what they are. So people assumed that this was an asteroid. Then they quickly realized after the observations that no, it's not in the asteroid belt. It's considerably further out than that. It's out in trans-Neptunian space. And all of this data didn't come to light, actually, until 2005 January. The observations, though, were actually taken in October of 2003. It just shows you astronomers do get behind. So, Sana, I'm okay with my delay on the paper. I'm not the only one who gets delayed in processing data. Okay, they made the announcement, as I said, in July of 2005, based upon data that was collected in October of 2003. And so UB313, as it was abbreviated to, or Xena, as they affectionately referred to it as, eventually became Eris. And it was initially thought to be, an asteroid. Then they did the calculations and realized this was a really big object. In fact, they initially believed it was larger in diameter than Pluto. Now, this was Mike Brown and company. They were out there searching for planet number 10. And when they found Xena, Eris, they thought maybe, just maybe, this is it. And as I said, the initial calculations suggested that the diameter of this object was larger than Pluto. Now, as it works out, it wasn't. It was actually just a little bit smaller in diameter than Pluto. But interestingly, it is more massive than Pluto. It's actually the 9th most massive object in the solar system. Okay, so after the 8 planets, you've then got Eris as the next most massive planet, next most massive object. So this was all in and around 2005, and because everybody was going, oh my gosh, if Eris is out there, maybe there are other trans-Neptunian objects that are comparable in size. And that sparked the huge debate about what do we actually call a planet? What are the rules and regulations that allow us to say an object is a planet? That came to a head in 2006 with the International Astronomical Union's meeting in Prague, and that's what generated the definition of a planet, which includes one of 3 clauses that Pluto and Eris failed to meet. As a consequence, Eris became a dwarf planet, as did Pluto. And so we have this new classification for objects in the solar system, as I say, dwarf planets. Eris, by the way, is actually the goddess of, get this, strife and discord. I think that works out really well, given the level of agitation that the discovery of Eris generated as far as Pluto was concerned. As I said, Eris is slightly smaller in diameter, 26 kilometers in diameter, slightly smaller than Pluto, but it is a little bit more massive, about 25% more massive than Pluto. In fact, the mass of Eris is around about a little over 1/5 the mass of our moon. So it is a sizable object in that regard. Its orbit is highly eccentric and is significantly inclined to the orbital plane, to the ecliptic, and has an orbital period of about 560 years. So it goes much further out than Pluto does. It rotates once on its axis every 26 hours and has one known satellite, Dysnomia, which briefly was referred to as Gabrielle. And for those people who watched the show Xena Warrior Princess, it makes perfect sense because they called Eris Xena for a while, and Xena's sidekick in the show was Gabrielle, and so therefore the satellite orbiting it, Dysnomia, was also referred to as Gabrielle. So, all the way back, July 2005, Ariella, the beginning of the end of Pluto as a planet.
Yeah, no, I have nothing nice to say at all.
You mean Mike Brown is not on your Christmas card list?
I have my favorite professor on, and Sana, I can't say anything rude, but afterwards I will be saying something rude.
This is a G-rated show, okay? So let us. Nonetheless, we have certainly found many dwarf planets out in the the area beyond Neptune. Eris and Pluto, regardless of what we want to call them, are just two of many objects comparable in size, comparable in mass, that orbit beyond the orbit of Neptune. So calling these objects trans-Neptunian objects is a catch-all, but the biggest elements out there, like Eris and Pluto, Makemake, Haumea, and so on, they do suggest that there's a lot more real estate in the outer solar system than we had ever really believed.
Very interesting. I still think Pluto's a planet. I don't care what Aries is, but
when I was training people at the observatory, one of the things I would tell them is to never say that Pluto's not a planet in front of you.
Oh yeah, I remember that. Well, that was the first way to get written up and sent to Delaney's office.
It generates passion, not just within the observatory team, but still out in the sort of amateur and professional astronomical communities. Very few things outside of Pluto's demotion, which, by the way, is coming up on its 15th anniversary next month. Okay, 15 years since that infamous discussion in Prague in 2006. It still rages on amongst amateur and professional astronomers. So it's not going to go away anytime soon. The definition of a planet as we currently have it is one that arguably is not particularly sound either. When we think about exoplanets, it's hard, for example, to qualify whether or not these objects orbiting other stars fit our definition of a planet in our solar system, because of course we can't figure out whether or not those exoplanets are clearing out their orbital path around their parent stars. We don't have the resolution to know that one way or the other, but nonetheless, it's nitpicking. Sana, you are infatuated with the moon tonight.
Yes, I am. So this is the Apollo 15 anniversary. There's a couple dates that fall within this week. So starting off on July 26th, 1971, at 9:43 a.m., Apollo 15 launched from the Kennedy Space Center aboard a Saturn V rocket. The crew consisted of Commander Dave Scott, Lunar Module pilot Jim Iron, and Command Module pilot Al Worden. This crew would be the fourth to land on the moon, but this mission was pretty different from all of the other Apollo missions. So first of all, it was the first of the J series of missions, which included several different upgrades to be able to accommodate longer stays on the moon. So one of this was an upgraded lunar module. They also had upgraded spacesuits to allow for more mobility and to extend the duration of moonwalks. And finally, they had the addition of lunar roving vehicles that they called the rovers, but I've also seen referred to as moon buggies, which I like, so that they could travel further distances when they were on their moonwalks. Another pretty important difference on this mission was that it was the first mission where one of the mission commanders had said one of the main goals of the mission is to do the maximum amount of science possible when they were on the moon. So, of course, all of the other Apollo missions did lead to a ton of scientific discoveries and were very important, but for a lot of those other missions, the mission commanders and the crews had a lot of other things going on, and it just wasn't, scientific discoveries and training for that wasn't as much of a priority as it was on this mission. But Dave Scott, who was the mission commander, was very enthusiastic about lunar geology and science, and he really wanted to make his mission stand out. So a part of that was doing as much science as they could possibly do while they were on the moon. To help accomplish this, he had for the first time integrated some geology training into their official training schedule. For Dave Scott and Jim Iron, who were the people who would be walking on the moon, this included some extensive training in field geology, even doing simulated moonwalks at some field sites, so that they could learn how to talk and think like geologists and identify scientifically interesting samples on their own. For Al Worden, who would be in orbit around the moon during that time, he was also training by taking flights around mountains so that he could practice the kinds of observations that he was doing while in lunar orbit. There was always some amount of science training for astronauts, but this was a lot more than they had ever done in the past, which was mainly up to the mission commander who would decide if they would do this or not. So Dave Scott was really into it and decided that they were all going to do as much training as possible for it. So all of this paid off during the mission.
Scott and Iron touched down on the moon on July 30th, 1971, aboard their lunar module Falcon near the Hadley-Ryle. I'm sorry if I mispronounce things.
Hadley-Ryle.
Hadley-Ryle, okay,
Yep.
in the Apennine Mountains. Am I saying that right? Apennine Mountains, thank you. So this was a much more rugged terrain than any of the previous Apollo landings, and it was also the first time that astronauts had visited the lunar mountains. So it was a little bit more risky than the stuff that they'd been doing before, but scientists were hoping that the astronauts would be able to get some pieces of the moon's primordial crust at this location, which was something that prior to this they had never had access to. So the risk at this point was definitely worth it to see if they could get a hold of that. So while they were on the moon, Scott and Iron did a total of 3 moonwalks, in total lasting 18 hours and 37 minutes, during which they traveled 17.5 miles, breaking records for the longest time spent doing moonwalks and the furthest distance traveled. During their moonwalks, they did a bunch of different things, which included deploying the Apollo Lunar Surface Experiments package and collecting the deepest core samples that had ever been collected at that point in time. And when they were further analyzed in the lab, they found 42 different layers in these core samples, some of which hadn't been disturbed for millions and millions of years. So it was a very valuable thing that they got there. They also visited several different craters, including Elbow Crater and the youngest crater that humans have ever visited on the moon. Additionally, they scaled the side of the Hadley Delta mountain and visited Spur Crater, where they took several interesting samples, including what might be the most famous of the rocks collected during the Apollo missions, which is called the Genesis rock. This was the rock that they had went to this area of the moon to get. It's believed to be part of the moon's primordial crust, with an age dated at 4.5 billion years old. So this kind of justified the mission right there. That was exactly what they were looking for. Well, on their final day of explorations, they visited the I'm going to say this wrong again. Hadley-Ryle?
Real,
thank you.
Yeah.
Real, sorry. They visited the Hadley-Ryle, where they became the first and only Apollo crew to find records of lunar volcanism that was preserved where it was formed. All of the other evidence for lunar volcanism that other Apollo crews had found were these pieces that had been scattered upon impact and were usually found around the rims of craters. But this was preserved where it had formed, which is pretty cool. But during all of this time, while they were doing a bunch of interesting things on the moon, there was a ton of science also going on in the command module Endeavour. It was a fully equipped orbiting lab, essentially, with instruments that included sensors to help map the chemical composition of the moon's surface, look for evidence of volcanic gases from the moon, and several different cameras, among other things. Al Worden, who was orbiting in the command module, also released a satellite into lunar orbit that was equipped with a magnometer to search for evidence of a lunar magnetic field. And that was the first time that a satellite had been deployed by a crew when in orbit around the moon. So after spending nearly 67 hours on the lunar surface, the longest of any of the Apollo missions at the time, Falcon lifted off on August 2nd and met up with Endeavour, where they spent some more time performing experiments before they returned home. So very, very successful mission, a ton of really amazing science that came out of this.
Yeah, I think getting humans back to the moon is something that should happen soon, is very important. 'Cause I feel like maybe Sana agrees. During my whole undergrad in physics, I never paid too much attention to the moon or wanting to study it. So I was like, oh, whatever, it's close. It's not cool like Pluto or in deep space. But now that you hear all this stuff that you can find about the history of our solar system and Earth, we should probably get some people back there to study it some more.
Yeah, I remember reading about how after Apollo 11 and the first couple Apollo missions, there was a lot of debate in NASA about whether or not there was a point in sending people to the moon, because there's always a risk associated with it. But the argument that people were making is that you got to keep sending humans, because even though you can send a rover who can collect samples and take pictures, humans can do so much more. They can be able to recognize something that's very important, and they can be able to describe things to you, and they can do so much more than robots can. So there's a ton of value in sending people instead of just probes.
No argument from me at all. The mission really was quite a landmark mission for all the reasons that you cited, Sana. It was also a spectacular scenery. The Hadley-Ryle area is absolutely gorgeous. If you spend some time looking at a lot of the images from that mission, the rolling mountains, the hills that the astronauts traversed with their rover, their jalopy, their moon buggy. Yeah, it was just fabulous scenery, and it was so very different to what we had seen on the Lunar Mariah. Those were flat, featureless plains, whereas we were up in the mountains here with the Apennine Mountains, and you can see the Apennines so clearly in a small telescope. They are big mountains. Some of them are literally 2-3 times the height of Mount Everest here on Earth. So we're talking about serious elevations. It really was a spectacular mission, and the rover performed beautifully. It allowed them to extend their range, carry a lot more payload, and the astronauts obviously enjoyed driving it. You could tell. Again, the imagery that was being sent back of the astronauts doing sort of rooster tails, with just spewing dust into the air as they made sharp turns and so on. Yeah, they had a grand time.
Yeah, I've been reading something about the Apollo missions, and apparently one of the reasons that they went to this site as opposed to another one that they had narrowed it down between those two was because Dave Scott said he wanted to go somewhere that was beautiful. And
yes,
he knew that this site was going to be amazing. So when he was asked which one do you prefer, he said, "Let's go here because it's going to be gorgeous."
And it was. He was absolutely right. That is for sure. It's such a shame, coming back to Ariella's point, we only really spent 3 really detailed science missions on the moon, Apollos 15, 16, and 17, to try and understand the full history of the moon from sort of 3 to 6 missions. Obviously just can't happen. So we do need to go back, and we need to stay. Don't leave the people, stay. And that looks as if it is going to happen with the Artemis project. So I look forward to the next few years, and hopefully you'll have the same level of excitement watching astronauts return to the moon as I had watching Apollo 11 back in '69 get to the moon for the first time.
Mm-hmm.
Yeah, I hope Sana and I can go. That way, if we just annoy each other and go on opposite ends, and we're good. It's not like the office at York where we can't escape each other. We're good.
If you do go, make sure you spare a thought for me. Okay. Okay, I'm going to take us all the way back to 1851, ladies. July 28th, 1851 was when the first photograph, at least usable photograph, of a solar eclipse was taken. There had been attempts made in the previous decade, but photography was in its infancy at that point in time, and none of the images were what you could call scientifically valuable. They were just sort of burned in white discs, shall we say, of the sun. That changed for the eclipse of July 28, 1851. The observer, Julius Burkowski, was at the Royal Prussian Observatory, basically Poland, and he, along with several others, it was actually quite the international team, managed to successfully collect an image of the sun, including the solar corona. Eclipses, of course, this particular eclipse was only visible from high northern latitudes. If you go and check the eclipse path, it ran through the very far north of Canada, skirted around the pole, and then went racing across northern Europe. It had about 221 seconds of totality, so a little under 4 minutes. Pretty standard solar eclipse. So it was a goodie to observe, and fortunately it went over the Royal Prussian Observatory. Really handy. How did you take a photograph of the solar eclipse back then? Well, believe it or not, they used a 16-centimeter refracting telescope to gather the light and an 84-second time exposure of the sun. Now, of course, we're used to taking images of the sun through neutral density filters for a fraction of a second, and the idea of even using a telescope, generally speaking, no, you don't need a telescope to collect light. But nonetheless, back in the 1850s, photography was really in its infancy. So there was quite the effort to get an image. And if you ever do see the image, because it has been preserved, it actually is really good. It shows you a couple of solar prominences. It shows you the inner corona. It doesn't show you the outer corona. It shows you the inner corona. It really was a surprisingly good image. Okay, so how do you take a photograph of the sun back in the 1850s? Well,
with a challenge, shall we say. It was what we refer to as a daguerreotype. Now, you probably have never heard of this, or if you have, hats off to you, because it's in history the only time in history when daguerreotypes were being used was in the 1840s and the 1850s. By the 1860s, it had given way to basically a safer version. What do I mean by safer? Well, okay, to actually go ahead and get a daguerreotype image, you actually have to polish up some copper with some silver. So you end up basically with a silver-plated copper surface, highly polished. You then make that surface sensitive to light, and you do that chemically. So you treat it chemically. Okay, don't breathe in the fumes. Once you've chemically laced the silver, you expose it to sunlight, and depending upon the angle that you're actually looking at the image later on, you might actually have either a positive or a negative image. It's a very interesting process in this regard. The way you actually develop up the image, so you've exposed your chemically laced silver-coated copper plate to, in this case, the sun, you now go ahead and seal in that image. Basically, you take away its photosensitivity using mercury vapor. Okay, warning, don't try this at home. Mercury vapor, really bad news for you. Okay, and then after that sensitivity has been removed, you then go ahead and coat the surface with glass or plastic, because, of course, it degrades very, very quickly. Daguerreotypes are not for the faint of heart. They are really quite a dangerous process, full of really degrading chemicals if you breathe them in. Nonetheless, Julius Bukowski was successful in gathering the first image of a total solar eclipse all the way back in 1851, and we can still see his work to this day. So, tip of the hat to him. I hope he didn't breathe in too many of those fumes.
Yeah. Why do I feel like Sana is going to now ask you how to get mercury vapor? Because, like, that just seems like it's on par after she asked for, like, the liquid nitrogen last time. Like,
well, liquid nitrogen far safer than mercury fumes. And so, no, I'm not giving her access to any mercury vapor.
I feel like this is something that I think is really cool and is, like, kind of want to try it, but I'm never going to, because I don't think it would end well.
Sana, don't you? I live too close to you to be in a radius to explode something. Don't.
It is interesting, though, that you ask about how can you do it, because there is a bit of a movement out there, and it's been a movement for the last 20 or 30 years, to rekindle daguerreotypes from an artistic perspective, because you obviously end up with a very different looking image. And for those who are looking for, shall I say, an interesting edge in their photography or their artwork, daguerreotypes have taken on a little bit of a resurgence in terms of their popularity. They will never replace the old Kodak cameras and the Kodak film, let alone your cell phones. But nonetheless, for those artistically inclined, there are many people who have rekindled daguerreotype technology. I am not one of them. Is that you not be one of them either? It is dangerous stuff. It really is.
But it looks cool. I gotta say that.
Yes, it does. There's no doubt about it. And those folks who did take daguerreotype images in the 1840s and 1850s, they did some really interesting work, and it paved the way for future photography. So, it was important stuff, but as I say, not for the faint of heart. It was challenging stuff. Ariella, finish us off for the night, please, as far as this week in space and astronomy history.
Yeah, so July 31st of 1969, Mariner 6 flew by Mars, being one of the first missions to Mars. So it also recorded the closest distance of 2,130 miles, which is also 3,429 kilometers. The spacecraft contained an array of scientific instruments, which included the visual imaging system, ultraviolet spectrometer, infrared spectrometer, and an infrared radiometer, which collected the most detailed data on Mars to date at that time. It flew over heavily cratered terrain, but missed the giant northern volcanoes. enormous equatorial canyon system, and a large outflow channels that were later discovered by Mariner 9 in 1972. However, the images did show that the dark features on the surface, as seen from earthly telescopes, were not canals, as they were interpreted as being in the late 1800s. The program objectives of the Mariner Mars 1969 project was to study the Martian surface and atmosphere in order to establish a basis for the future experiments in search for possible extraterrestrial life. It wanted to develop the technologies for future Mars missions and to demonstrate engineering concepts and techniques and mission operations required for long-duration flights away from the sun. The Mariner 6 mission nearly failed before it even launched. On February 14th of 1969, 10 days before its scheduled launch, the Atlas Centaur rocket began collapsing under its own weight due to a faulty switch that opened the main valves that pressurized the Atlas's first stage. Not a good way to spend Valentine's Day. The rocket deflated and began crumpling, and the mission would have been totally lost if not for the bravery of two ground crewmen. Bill McClure and Jack Beverland rushed to the launch pad, risking their lives to close the valves and start the pumps to repressurize the 124-foot-tall launch vehicle. The two guys were awarded the Exceptional Bravery Medal from NASA, becoming the first recipients of this honor. Their Mariner 6 spacecraft was removed, placed on another Atlas Centaur, and unbelievably launched on schedule February 24th of 69. Mariner 6 flew over the equator and imaged a band down to 10 degrees south, showing the various dark and light features near, I'm not going to pronounce this, Sinus Meridiani?
Close enough.
The Mars exploration rover Opportunity would land in this region 35 years later. During a period of 17 minutes, Mariner 6 acquired 24 near-encountered images that showed heavily cratered areas, chaotic terrain, and the South Polar Cap. Instruments indicated that the polar cap gave off infrared radiation consistent with solid carbon dioxide ice. Some 98% of the Martian atmosphere was found to be made up of carbon dioxide. So this obviously was a huge success and it got really close. And when I was researching and reading this, I decided I wanted to read more on the Mariner missions because I don't actually know too much about them. They seem like they really helped our understanding of Mars to bring us where we are now to being somewhat closer to sending people to Mars.
The Mariner series, in fact, was phenomenally successful, not just for Mars. They had our first trips out to Venus, and they paved the way in terms of technology for the Pioneer vehicles that flew out to the outer solar system, and they in turn led to the Voyager spacecraft. In many ways, it was Mariner that paved the way for Voyager.
Amazing. So cool.
Yeah, and there were actually two missions. It was the Mariner 6 and 7 that flew to Mars. I know you were just focusing on Mariner 6, which is cool, but they were actually a pair of spacecraft. Back in those early days, we tended to launch them in pairs simply to increase the likelihood of success. And so Mariner 6 and 7 both launched successfully, in contrast to Mariners 3 and 4. Mariner 3 got up close and personal with the bottom of the Atlantic Ocean. And Mariners 8 and 9, Mariner 9 made it to Mars. Mariner 8, again, made it to the bottom of the Atlantic Ocean. So, it was a challenging time there in the 60s. And Mariner 6 and 7 were both surprisingly and amazingly successful. And I did not know that there were two guys who risked their lives to get it off the ground. That was a piece of information I had not heard.
Yeah, that was incredible when I read it. Like, they just risked their whole lives, and it worked out well because we got the mission, and they also got a really awesome medal. So, I mean, I think they should be known for the mission. But
absolutely. My gosh, going out and turning some valves on a rocket that is basically one big bomb that's crumpling around you. Not my idea of a good plan. Oh. Really? But nonetheless, they did it. So, yeah, hats off to them. Folks, you're listening to York Universe, the weekly broadcast of astronomy and astrophysics out of the Alan I. Carswell Observatory here at York University in Toronto, Ontario, Canada. Ariella, Sana, myself, Paul, keeping you company for this week in space and astronomy history. By all means, point your favorite web browser to observatory.info.yorku.ca and follow the links to the online public viewing. Join the observatory team there as they scoot around the sky with our 1-meter telescope, and by all means, ask them any questions. Sana, we've got some meteor activity coming up.
Yes, we do. So it's the peak of the Delta Aquariid meteor shower on July 30th. July 30th is the peak, but it is going to be visible for a couple weeks on either end of that. So if it's not clear on the 30th, you can't make it out, don't worry, you're not going to miss it.
This meteor shower is best viewed from the southern hemisphere, but it is visible in Toronto with a rate of about 25 meteors an hour. The radiant point, which is in the constellation Aquarius, will be pretty low on the horizon in the south. It's rising to an altitude of about 30 degrees a few hours before sunrise, so it's best to observe it around then. Normally you want to observe them around midnight because that's when the sky is darkest, but in this case, you need it to have a bit of altitude before you can observe it. And as always, whenever you observe meteor showers, just get as far away from the light pollution as you can because you'll increase how many you see. So another cool thing about this is that Jupiter and Saturn are going to be very close to the radiant point. So while you're out there observing the meteor shower, you can take a look at them also. Finally, one more thing to mention. There's going to be several good ISS passes this week around Toronto. There's a couple especially good ones on July 28th, 29th, and 31st at around 9 to 10 p.m. But the exact time that they come overhead depends on your location. So check Heavens Above or Spot the Station to get exact times.
Ooh, very good. Actually, having Jupiter and Saturn in Aquarius, very, very handy. Great signpost there in the south. And a good warm-up, so to speak, for observing the Perseid meteor shower, which is sort of like about 2 weeks later on August 12th. By all means, folks, remember, we are also live on Wednesday evenings from 7:30 to 8:30. Our Teletube on YouTube. Again, pop onto YouTube. Have a look at, if you're listening to the online public viewing, it's the same link on Wednesday night. But failing that, if you're not over there at the moment, on Wednesday, 7:30 to 8:30 local Toronto time. So that's Eastern time here in North America. Tune in the Observatory team as they talk about a topic of interest to them and field questions, on the chat. So feel free to ask an astronomer, so as to speak. That's this coming Wednesday. And just a tip of the hat, Jeff Bezos and the Blue Origin crowd launched New Shepard successfully last Tuesday, July 20th. They went to the edge of space, about 100 kilometers or so above the surface of the Earth. Jeff Bezos, Wally Funk, and a couple of other folks, 4 of them, got their astronaut wings in a really picture-perfect flight. And that was, of course, the second space tourist flight in 10 days. Richard Branson of Virgin Galactic on July 11th, Jeff Bezos and company with Blue Origin on July 20th. So, ladies, you are getting closer to being able to spend a weekend in Earth orbit if you so choose.
Can you imagine being taken on a date to space for the weekend?
Sorry, my wife has already booked that, so can't offer it to you. No, not at all. Well, but you're right.
Let's hope my partner's listening, because that's...
Okay, so he's got a really good paying job, right? That's the other thing at the moment.
As long as we can work to up the PhD pay, we're good.
Excellent. I'll get right on that. Okay, we've got 3 items that we need to slip through here, ladies. In honor of your Mariner 6 commentary about Mars, I just thought I would give a quick update on the InSight lander that landed in November of 2018. This was a NASA probe that, unlike all its other probes, was designed to look at the Martian interior. Every other probe that you can think of, all the way back to Mariner 4, has been looking at the surface features, the atmosphere, looking at the evolution of the planetary surface, chasing water, all that sort of good stuff, which is really exciting, but nonetheless doesn't tell you a whole lot about the interior of Mars. Well, InSight changed all that, and while it had 3 principal instruments on board, one of which its famous MOLE, designed to measure heat flow, it did not work. Sorry, MOLE didn't work very well, couldn't get itself down through the Martian surface. The other 2 instruments have worked really well, particularly the seismometer. And so they have been probing the Martian interior pretty well continuously for the last 2+ years. And they've now got a bit of a handle on the Martian interior. You're listening to earthquakes or Marsquakes, energy waves propagating through the Martian interior. And just like here on Earth, listening into the differing types of waves, the primary waves, the shear waves or secondary waves, gives you insight into the material through which those waves are passing. And of course, when you're paying attention to both the time elapsed of these different waves reaching your observing station, in this case, the InSight lander, then you can get information about the interior structure and, of course, how thick those differing layers are. So not just composition, but the extent of those compositions. With only one observing station, however, it is a bit of a challenge. It's sort of, on the Earth, we have hundreds, probably thousands of observing stations. On the Moon, we have several seismometers deployed. But on Mars, despite our best efforts, we landed seismometers in 1976. Wasn't very successful, though. The InSight lander is the first fully functioning seismometer. So it is only one ground station, which means we can't constrain the models for all of the data we are picking up. So that's the bad news. We've picked up about 1,000 differing Mars quakes over the last 2 years, but only about 10 of them are what we would call deep quakes. The other 990 or so are relatively shallow, very gentle, sort of gentle rumblings. But 10 have actually produced data with waves that have both moved around the surface as well as penetrated deep into the interior of Mars, reflecting off the various layers, including the core, and coming back. So we've had 10 really good waves, earthquakes with waves. We want more, is the bottom line to it. Okay, so what are the quickie takeaway messages so far with respect to these 10 that have now been mercilessly analyzed? The crust seems to be a little thinner than we were anticipating. The Earth's crust varies from only a few kilometers on the ocean floor up to about 70 kilometers across the continental land masses. On Mars, the thickness of the crust, and again, remember, one data point, one seismic station, does not constrain it as much as we would like, but it looks as if we might be somewhere in the vicinity of 20 to 30 kilometers. Could be, in fact, as thin as 10, but it's more likely 20, 30, or 40 kilometers, considerably thinner than the crust here on Earth. And the crust seems to be delineated into 2, maybe even 3 differing layers. It's a little denser. In fact, surprisingly, the mantle is less dense than the crust. That's a bit of a surprise because through the theory of differentiation, you should have increasingly dense layers as you head towards the core. Not so on Mars. The mantle is pretty substantial in size. In fact, percentage-wise, it's larger than the Earth, but it is lower density than the crust. Bit of a surprise in that regard. All of the data we've got for the mantle suggests that it's an undifferentiated material. That is to say, it hasn't structured itself by density. It seems to be still well mixed, a bit of a surprise. The data suggests that there should be a much higher amount of radioactive materials, or at least heat-generating materials, in the upper layers than we are currently seeing. All of our data from orbit suggests that the amount of radioactive material in the crustal environment is very little. The data we're picking up with this structure of the mantle and the crust is suggesting there should be much more radioactive material in the crust than we are currently picking up. The core appears to be larger than we were expecting, which means its density is lower, right? Density is mass over volume. The amount of material that is in the core is now filling a larger volume, which means it's lower density, which of course is a bit of a surprise, but it is molten. Now, you've got a molten interior. It's a slightly higher density. You might think that that should produce a good magnetic field. No, the magnetic field froze out on Mars about 3.7 billion years ago because of this lower density environment inside the core. So there's lots of good stuff that's coming out of InSight's interpretation of the interior, but we need more seismic stations to be able to constrain the models. I mean, given enough free variables, you can make sort of, almost anything of the data. We need more deep Mars quakes and
preferably more seismic stations to help constrain what we're seeing. So InSight is doing a good job with its seismometer. We can hopefully receive more data in the near future. I'm going to push us on here because we've got 2 more news items. Ariella, would you like to take it away, please?
Yeah, so I'll just quickly go over that astronomers saw moons forming in the disk around a distant exoplanet. So as we know, our solar system is home to a variety of different moons, and astronomers have discovered about 4,438 exoplanets orbiting other stars, but we haven't found exomoons yet because they are too small and too far to be spotted. Now, after years of observations of a pair of Jupiter-like exoplanets nearly 400 light years from Earth, astronomers have found a disk of debris orbiting one of these exoplanets. There seems to be a ring of rock and gas gradually coalescing under its own gravity. In other words, astronomers have caught what seems to be the necessary to making moons. This is the first time such a feature has been detected. The disk was effectively photographed, a real image of an exoplanet surrounded by its very own moon-making forge. Very cool, and I really want to see this photo. This discovery, reported Thursday in the Astrophysical Journal Letters, will help scientists address one of the most perplexing questions in astronomy. How do planets and their moons form? Possible answers have been hypothesized for years, from titanic impacts to the gluing together of spaceborne hail, where the force of gravity may battle disruptions from magnetic whirlpools that exoworlds have thought to encounter. The solar system is 4.6 billion years old, as we might know, and this is only seen as middle-aged, so anyone here on Earth must feel very young. This distant star system, with the soon-to-be-forming moons, in contrast, is in its early childhood. The star the 2 exoplanets travel around is PDS-70, which was born 6 million years ago. The star has its 2 Jupiter-like planets, PDS-70b and PDS-70c, which are still present. As new planets are slowly pieced together, the 2 YAOS that already exist continue to siphon off disk debris and fortify themselves with it. The Very Large Telescope in Chile's Atacama Desert found both exoplanets, with PDS-70b's discovery announced in 2018 and PDS-70c's in 2019. A month later, scientists using Chile's Atacama Large Millimeter Sublimeter Array, I'll just call it ALMA, reported that radio waves emitted by fine dust were emanating from around PDS-70c, promising evidence that a moon-making debris disk surrounded it. The signal, though, was faint. Dr. Benesty, who's a scientist on the project, and her colleagues used ALMA to conduct follow-up observations, demonstrating that with little doubt, the PDS-70c has its own disk of debris, enough to make 3 moons the size of Earth's satellite. Very cool that there'll be 3. In the coming months and years, increasingly powerful telescopes and space observatories will soon become operational. So soon, the first will be captured on camera. One day, perhaps we will capture an exo-Earth on camera, and the only thing you should get out of that is that astronomers cannot name things. The PDS-70c and B are just not good names. Anyways, that's all.
It sums it up very well indeed, that's for sure. Now, ALMA is really proving its worth, and it just shows you that you can get wonderful, wonderful insights into astronomy without necessarily using optical telescopes. Sana, can you give us just a quick summary of your story, please?
Sure. So there are some new interesting pictures out of the Event Horizon Telescope. This time they were imaging some jets out of the galaxy Centaurus A. So the Event Horizon Telescope first produced some images, the first images of a black hole with its observations of Messier 87, but now it started looking at not only black holes, but the environment surrounding them, which had led it to Centaurus A, which is the brightest and biggest radio galaxy in our sky and is also one of the closest radio galaxies to the Earth. It has a supermassive black hole at its center, which is causing a couple massive jets. That these things are absolutely huge. They are several times bigger than the galaxy itself. So these observations had looked at the jets to try and figure out some mysteries about, you know, how do these things form and how do they evolve. So that's the quick summary.
Sorry about that. Didn't give you a whole lot of time. But yes, the Event Horizon Telescope has really shown some phenomenal capability in terms of its resolving power. I mean, thinking about the entire planet Earth being used as a radio telescope. Oh boy, that's pretty impressive. I look forward to seeing Sagittarius A star in the not so distant future.
Me too.
Folks, you've been listening to York Universe, the weekly broadcast of astronomy and astrophysics out of the Alani Carswell Observatory. Sana, Ariella, myself, Paul, keeping you company tonight. Please stay tuned for the rest of Astronomy Night in Canada with Western World's Science for the People and Quirks and Quarks. We'll see you again 2 weeks from now. It's a holiday next week. See you in 2 weeks. Good night.
Good night.
It's really easy to find us. We are astronomy.fm. You may also find us in the iTunes radio listings near the top of the News Talk section, and also as an iTunes podcast selection. We'd love to hear your comments. Please email us at radio@astronomy.fm. Thanks so much for being part of the voice of astronomy around the world and across the known universe. This is astronomy.fm radio.
AFM.